Welcome back, everybody. We are looking at exercise 1, and we are still on page 19 of the workbook here. This is going to be our first example of calculating a derivative. Okay, let's read this question together. So they're giving us a function f of x equals negative 7 plus 6x minus x squared. They give us a graph of the function over here to the right. And they'd like us to use the limit definition of the derivative to calculate f prime of 4. Now, when they say limit definition, what they're referring to is this formula up here that we wrote down. Okay, that's what we're going to be using to calculate the derivative. Okay, and then they ask us, what does this number represent geometrically? Let's maybe start with that part, the very last sentence in the question here. Okay, so we made the comment that the derivative is about the slope of the tangent line. So geometrically, what we're looking for is the slope of the line that you would get if you find the number 4, okay, and draw in the line tangent to the function there. Okay, so I'm going to call that t for tangent line, and the slope of that line, whatever it is, should be our derivative. Okay, now before we do the calculation, can you tell from the picture whether that line would have a positive or a negative slope? What do you think? Okay, you see how that line goes down left to right? That's probably going to have a negative slope, so we would expect to get a negative derivative here. Okay, let's see if that's what happens. Okay, so to calculate f prime of 4, okay, again, we're going to go back to this formula that we have up here. And the first thing to notice is that the number 4 that we have here, that's the value of a in our definition. Okay, the number right there, if we look back up at the definition for a second. All right, so we want to go over here to the right, okay, in our definition, and just fill in 4 for all of the a's. That's our starting point. Okay, so jumping back down here again, we're going to be taking the limit as h goes to 0 of f of 4 plus h minus f of 4 over h. That's what we need to calculate here. Okay, well, how do we do this? Well, we need to remember what this function notation is telling us. So starting with the 4 plus h here that we're substituting into f, remember that we're thinking of that as an input. That's an x value, and that x value is going to go into our function up here. Everywhere that you see an x is going to go a 4 plus h. Okay, so we will take our formula, negative 7. Everywhere that we see an x, we're going to put a 4 plus h. Okay, and that's going to lead us to that. Okay, so what we just wrote down is f of 4 plus h. The next thing that we see is f of 4. Same idea there. This time 4 is the number that we're substituting in. So we're going to take 4 and plug it in for every time that we see an x in our formula for f. So we'll get negative 7 plus 6 times 4 minus 4 squared all over h. Okay, so that's what we need to calculate here. All right, let's see what happens here then. So first thing, we can maybe do a little simplifying. So the 6 times 4 plus h, we can distribute the 6 through and get 24 plus 6h. Okay, and then the next thing that we see is minus a 4 plus h squared. We could FOIL that out. 4 plus h squared, if we multiply all that out, is going to be, let's see, 4 times 4 is 16. Then for the two middle terms, we're going to get a plus 4h and a plus 4h. That's going to give us a plus 8h. Okay, plus an h squared. Okay, and then the next thing we come to is this group of numbers here, negative 7 plus 24. Let's just write down what those numbers are. Negative 7 plus 24 minus 16. Okay, if you do the arithmetic there, that's going to work out to a 1, I believe. Okay, and that's inside the parentheses. So we are going to just get a minus 1 then for that piece. All right, and so far we're looking at that. Okay, and continuing with this, let's see. Any simplifying we can do here? Okay, I'm just going to rewrite the first part of this. Negative 7 plus 24 plus 6h. And then looking at this part, we could take the minus sign out in front and just distribute it through. Okay, minus 1 over h. Okay, maybe one question that I could ask you here, we're trying to take a limit of this function, and why is it that we can't just substitute in h equals 0, since that's what we're approaching? Okay, well, the problem is this 0 denominator. If we tried to substitute h equals 0 in, we would get a 0 in the denominator. We can't do that. That's kind of why we're doing all of this algebra. We're trying to simplify this into a form where we no longer have a 0 in the denominator. Okay, so let me clear that clutter away here, and we'll continue with this calculation. All right, and so what we're hoping is that we can get some cancellation here. And I'm going to start by circling all of the constant terms. So we've got a negative 7 plus a 24 minus a 16 and minus a 1. If you take those four numbers and add them all together, what you discover is that they all cancel out. You get 0. Okay, so I'm just going to cancel those all away. And then the next thing we might notice is that 6h and negative h, those are like terms that we can add together. So 6h minus 8h is a minus 2h, minus h squared. Okay, now we're getting close. And notice that we can factor an h out of the numerator. So we'll get h times a quantity negative 2 minus h. And factoring that h out is kind of the key step, because now we can cancel these h's. Okay, and so last thing to do, now that we got that h to go away in the denominator, we're free to substitute in what h is approaching. H is approaching 0, so the h that you see here, we're just going to substitute 0 in for it, and we're going to get negative 2 minus 0, which is negative 2. There's our answer. Okay, and back to the comment that we made at the beginning. So we looked at our picture, and the slope of the tangent line kind of made the observation that the slope looks like it's negative, and notice that we did get a negative number. Okay, negative 2, that is the slope of the line that we have up here. Okay, and I'm going to remind you of that just by writing it one more time. That's the slope of the t that we drew in the picture above.